Thank you for your introduction. Today I'm going to talk about our work, TinyLink 2, which is an integrated approach for developing IoT applications. As we know, an IoT application usually contains three parts: the device side, the cloud side, and the mobile client side. How to accelerate the IoT application development is an unsolved question. Take a smart curtain application as an example. This application contains a smart curtain device, which will open if the room is too dark during the daytime, and a mobile UI that displays the light intensity and controls the curtain. But developing this application is not easy because it has so many building blocks, and the development language for each size are different. There are some existing works to achieve rapid development for the three sides. But we can see that existing works focus on the development of only one side, so we need an integrated approach for all the three sides. This is what we have done. TinyLink 2 integrates the three sides in one piece of code and generates the IoT application automatically. Developers only need to write the application logic using TinyLink 2 language for the three sides in one piece of code. Such as the smart curtain example, it only needs 28 lines of code. Then they need to feed the code to our system. Our system will generate the output for the three sides. The output of each side is then distributed to the corresponding hardware for execution. Building such an integrated development system faces non-trivial challenges. First, how to design the TinyLink 2 programming language to make it easy to use and expressive. Second, how to generate an application with the best performance. We now talk about how TinyLink 2 cope with these two challenges. First, let's dive into the programming language design of TinyLink 2. A TinyLink 2 application is written in three parts. The application logic is described in the FTDT-like rules. The TinyApp model defines the behavior of an IoT device or mobile client. We also provide UI-related APIs for mobile application development, such as the UI button and UI chart. But this language design still have unsolved questions, which are expressiveness and simplicity. For the expressiveness, we enhance the FTDT rules with new keywords to cope with controlling multiple devices or interfaces. To simplify the AI development, we introduce the virtual sensor mechanism. And developer could only set the input sensor and the output event. TinyLink 2 will automatically choose a model, obtain the necessary data, and train it. Except for the TinyLink 2 language, our system also performs both static and dynamic optimization to minimize the energy consumption of the generated application. The takeaway message is that the static optimization is to statically choose the policy execution location. The dynamic optimization is to dynamically schedule the sensor data uploading interval. The formulations and methods we used could be found in our paper. Up to now, we introduced the core building blocks of TinyLink 2, both language design and performance optimization. We implement the whole process of TinyLink 2, and then we conduct detailed experiments with this setting. In the evaluation, we focus on answering these three questions: the acceleration, expressiveness, and energy consumption reduction. The evaluation results are listed in this slide. So, to recap, TinyLink 2 is an integrated development approach for IoT applications on the device, mobile, and cloud side. We propose a coherent language that accelerates the development and the two optimizations for better energy efficiency. That's all from me about TinyLink 2, and I'm happy to take some questions.